Atoms, molecules, and chemical bonds. Sounds kind of boring, right? But what we are talking about is you. You are a form of matter, and if we could break you apart into your smallest subunits, you would be comprised of atoms such as carbon, hydrogen, oxygen, and nitrogen. Therefore, this section discusses the smallest structural components of your own body. Matter is anything that takes up space and has mass. You are matter, the chair you are sitting on is matter, the desk or table you are sitting at is matter, and the computer screen you are looking at right now is matter. If we could break matter down into its smallest structural components, all matter is comprised of atoms. An element is a substance that can neither be broken down nor converted to other substances by ordinary chemical means. By ordinary chemical means, we are referring to the chemical reactions that take place in your cells. The periodic table of elements depicted on the next slide shows the elements in order of size from smallest to largest. Remember the atoms mentioned at the beginning of this chapter? Carbon, hydrogen, oxygen, and nitrogen comprise 96% of human body weight. The periodic table shows the atomic mass and atomic number of each element. The atomic number appears above the symbol for the element, and the atomic mass appears below it. Atoms are the smallest piece of an element that retain its chemical characteristics. As mentioned earlier, atoms are the basic structural units of matter. If we could cut a diamond, which is a form of carbon, into smaller pieces, each piece is still comprised of carbon. And if we could divide the diamond into its smallest structural subunits, those would be individual carbon atoms. Atoms are made of even smaller subatomic particles, including protons, neutrons, and electrons. Protons have a positive charge, neutrons have a neutral or no charge, while electrons have a negative charge. Protons and neutrons reside in the atomic nucleus in the middle of the atom, while electrons orbit around the outside. In a native atom, the number of electrons is equal to the number of protons, therefore it has an overall neutral charge. However, discussed later, certain atoms may gain or lose electrons to form what's called charged ions. Elements such as helium, depicted here, are made up of atoms. Atoms are made up of protons and neutrons located within the nucleus, with electrons and orbitals surrounding the nucleus. There are right around 92 naturally occurring elements on Earth that correspond to 92 different types of atoms. The atomic number, which defines each atom, is the number of protons in an atom. This is different for each atom, and it never changes for a specific atom. Mass number is equal to the number of protons plus the number of neutrons. The mass for electrons is so negligible that it is not factored into this equation. Many atoms exist as isotopes, and these are atoms of the same elements that have different numbers of neutrons. One example is carbon, which has 3 naturally occurring isotopes, carbon-12, carbon-13, and carbon-14. Carbon-12 has 6 protons plus 6 neutrons. Carbon-13 has 6 protons plus 7 neutrons, while carbon-14 has 6 protons plus 8 neutrons. As mentioned earlier, the number of protons will never change. If we took the average mass of all isotopes, this would be equal to the atomic mass. As I mentioned, there are 3 naturally occurring isotopes for carbon, but only 2 of them are stable, as depicted here. Carbon has an atomic number of 6 and 2 stable isotopes with mass numbers of 12 and 13 respectively. Its atomic mass is 12.11. Isotopes may exist in a radioisotope form, meaning that they are radioactive. These are unstable isotopes that emit energy called radiation. Radiation can damage the body or lead to cancer. Consider the fact that if you are overexposed to ultraviolet radiation from the sun, this can cause skin cancer. On the flip side, radiation can also be used in medicine to generate X-rays, other imaging techniques such as CAT scans, or for killing cancer cells. What you should keep in mind is that you should also limit your exposure to medical radiation. For instance, if you have x-rays at the dentist on your teeth, they will place a metal apron over your chest and abdomen to protect your internal organs. Radiation kills cancer cells by damaging the cancer cells, but it can also damage your own healthy cells surrounding the cancer cells. Two or more atoms chemically bonded together is referred to as a molecule. This can consist of the same or different atoms. For example, the oxygen that you breathe from the air is actually molecular oxygen consisting of two oxygen atoms bonded together. Water consists of two hydrogen atoms plus one oxygen atom. A compound refers to a molecule composed of two or more different elements. While water is a compound, oxygen is not. When it comes to charges, opposites attract. Therefore, electrons are attracted to positive protons in the nucleus, but they repel one another to spread out. Electrons reside in what's called energy shells. These are regions where electrons orbit that correspond to a fixed energy level at a given distance from the atomic nucleus of the atom. Each shell contains a certain number of orbitals, which represents the most likely location for an electron at any given point in time. Each orbital can contain two electrons. The Bohr model was developed by Niels Bohr in 1913. In this model, electrons exist within principal energy shells. An electron normally exists in the lowest energy shell available, which is the one closest to the nucleus. The innermost shell, represented by 1n here, can hold up to two electrons, so it has one orbital. Remember that each orbital can hold two electrons. The electrons in this shell have the lowest energy level. The next shell outward, represented by 2n here, can hold up to 8 electrons, so it has 4 orbitals, and these electrons contain more energy than those in the 1n shell. Each progressively outward shell, whether it be 3n or 4n or higher, can hold up to 8 electrons, and each outward shell has progressively greater energy levels. It's the size of the atom and therefore the number of electrons that will determine the number of shells that an atom will have. Orbitals exist in two shapes. Spheres referred to as s orbitals and dumbbells referred to as p orbitals. Remember that each orbital can hold 2 electrons. Therefore, the first energy shell with 2 electrons total contains only one s orbital. Since each progressively outward energy shell can hold up to 8 electrons, these shells each contain 1s and 3 p orbitals. Atoms are held together by interactions amongst their outermost electron shells called valence shells. Atoms are most stable when their outer electron shells are either completely empty or full. While this might sound like opposite points, if the outer shell becomes empty, the next remaining outermost shell is actually full. An inert atom is an atom in which the outermost electron shell is completely full or empty. Therefore, this atom will not react with other atoms because it is stable and does not need to react to fill or empty its shells. A reactive atom has a partially full outermost shell, and in this case it will react with other atoms to either empty or fill its outermost shell. This results in chemical bonds, which are attractive forces that hold atoms together to form molecules. Bohr diagrams indicate how many electrons fill each energy shell. Group 18 elements, which are elements found in the rightmost column of the periodic table, here helium, neon, and argon are shown, have a full outer or valence shell. A full valence shell is the most stable electron configuration. Elements in other groups have partially filled valence shells and gain or lose electrons or share electrons to achieve a stable electron configuration. A covalent bond is a chemical bond in which atoms with partially full outermost shells share 2 or more electrons to fill their outermost shells. This is the strongest type of chemical bond, and therefore most biological molecules use covalent bonding. A nonpolar covalent bond is a covalent bond that has equal sharing of electrons. A polar covalent bond is a covalent bond between a pair of atoms in which one atom is more electronegative, meaning that it has a greater attraction for the electrons. Because one atom in the pair has a greater attraction for the electrons will spend more time around that atom, and this atom will take on a relative negative charge, while the other atom in the pair has a relative positive charge. Two or more atoms may bond with each other to form a molecule. When two hydrogens and an oxygen share electrons via covalent bonds, a water molecule is formed. Whether a molecule is polar or nonpolar actually depends both on the bond type and molecular shape. Both water and carbon dioxide have polar covalent bonds, but because carbon dioxide is linear, the partial charges on the molecule cancel each other out. Methane, depicted in the middle of this figure, contains only carbon and hydrogen, which share electrons equally, giving nonpolar covalent bonds and therefore a nonpolar molecule overall. Atoms are most stable when their outer electron shells are either empty or full, which makes them inert. To achieve this goal, atoms can either lose or gain one or more electrons to empty or fill their outer shells. This results in an ion, which is a positively or negatively charged atom. Keep in mind that electrons are negatively charged. So if an atom loses an electron, it takes on a positive charge. If it gains an electron, it takes on a negative charge. Ions with opposite charges form an ionic bond, which is an electrical attraction between oppositely charged ions that holds them together. If you have ever put table salt on your French fries, you are sprinkling crystals of sodium and chlorine atoms that are held together via ionic bonds. Sodium, abbreviation Na, based on Latin, loses one electron to empty its outermost shell, which is picked up by a neighboring chlorine atom, which only needs one additional electron to fill its outermost shell. This results in a positive sodium ion and a negative chloride ion, which are attracted to one another to form an ionic bond yielding sodium chloride or table salt. Water molecules attract one another to form hydrogen bonds. Remember that within a water molecule, partial charges are established by the polar covalent bonds holding together hydrogen and oxygen. The partially negatively charged oxygen atoms are attracted to the partially positively charged hydrogen atoms in different water molecules to hold neighboring molecules together to yield a pool of water. While hydrogen bonds are weaker than both ionic and covalent bonds, they are still important in many biological molecules. Remember that water forms polar covalent bonds to establish partially negatively charged oxygen atoms and partially positively charged hydrogen atoms. These partial charges are attracted to one another in neighboring water molecules to form stable attractions between different water molecules to yield hydrogen bonds which hold water molecules together in a pool of water. Remember chemical bonds? These are generated by chemical reactions that make and break chemical bonds to form new substances. During a chemical reaction, one set of chemicals is converted into another set. The starting set of chemicals is called the reactants, while the finishing set of chemicals are called the products. For example, during photosynthesis, plants utilize the energy of sunlight to convert carbon dioxide and water to glucose and oxygen.